And so something can be modeled as a straight line. Okay, so this one is the extension of a spring when different masses are attached to the end. Okay, so like the heavier the mass, the greater the mass, the more the spring will extend.
Yeah.
Okay, part A.
So when working out the gradient for this, could you just look at the line and then count 4 to the right and up to?
It might be, but what would it be exactly? Is there any coordinate on this line?
What do you mean?
Like, can you find an exact coordinate on the line? Like 4 to the right, 2
Yeah,
up.
like 105, but yeah.
Yeah, 105. 5. For these ones, there's the simplest point, which is 0, 0.
Yeah.
And so, okay, so gradient.
Is that y2 minus y1 over x2 minus x1?
Yeah.
So it'd be 0 minus 5 over 0 minus 100.
Yeah.
Which is 1 over 20 or 0.05.
Okay. 1 over 20. 0.05. B.
So would be written as should it be something like E over M?
This is a different way of saying y equals mx plus c. That's what they're looking for.
Okay. So to be y equals EX plus M.
Don't worry about E and M. Just y equals mx plus c. What's the equation of the line?
What, like do the equation of the line?
Yep.
Okay. So it'd be y equals 1 over 20x.
1 over 20x, yeah, like plus 0, because this y-intercept is 0, or just y equals 1 over 20x. Except in, maths world, this is x, this is y.
Yeah.
In this case, this is m, and the y is e. And so replace x with m, y with e.
What so be E equals 1 over 20 m.
Yeah. So it's a bit confusing that m is gradient and also mass in this case. But that's it. That's all they're talking about. It's the equation of the line, but using the kind of real world letters for this situation. What is this? Explain what the value of k represents in this situation. So k was the 1 over 20 or 0.05. So in this situation, what is the practical interpretation of k?
Pardon?
So in this situation, what does k represent? 0.05.
The gradient.
But like in the real world situation of a mass being attached to a spring and the extension of the spring, any idea what the gradient represents?
Like the length of it being extended.
Yes. So for this one, you have to show the connection. So the gradient is like for every one right, how many up does the line go? In this case, for every one right, this line goes up by 0.05.
Yeah.
And so we would say for every 1 gram increase in mass, there is a 0.05 centimeter increase in extension of the spring.
Yeah.
Extension of spring. In general, so it's like a practical interpretation of the gradient. In general, it's for every 1 increase in x, there is an m increase in y. Instead of saying x, I say mass. Instead of saying y, I say extension of spring. And instead of m, it is 0.05 centimeters. So in general, for all of them, the practical interpretation would be for every 1 increase in x, there is a m increase in y. And you just fill in whatever x, m, and y are in the particular thing. So pure maths, it's just gradient. It's like one right 0.05 up to get back on the line.
Yeah.
In this case, applying it to the real world. Let me see. K represents the increase in extension in centimeters when the mass increases by 1 gram. So it can be kind of tricky how you phrase it, but phrasing it like this will work for all situations. So any questions about that?
No.
Okay, so this one was y equals mx plus c, and you're just using their letters. Just want to see something here. Okay, what would be first one? 1a.
Okay. So it'd be 0 minus 100 over 0 minus 2.
Yeah.
Okay. Which is 50.
Part 2.
So it'd be D equals 50t.
Well done. And I'm going to put in part 3. Write an interpretation of the value k. What does the value k represent?
The value of k represents, so when the time is increased, the distance is also increased. So k is also increased, but that's like the gradient, so it's like in between both of them.
So for every 1 increase in time, distance increases by how many meters?
50.
Yeah, there's a 50 meter increase in distance. So that seems like a very strange way to say it. It's basically every second it travels 50 meters, or it's basically 50 meters per second. And so for speed, so for distance time graphs, that gradient gives you speed, but this phrasing will work for all situations.
Yeah.
Okay, Grant, I think you're good. Let me see this one. This is what the exam questions look like. Draw a graph of the data. How do you draw a graph of this data?
Uh, does it matter which is on the x and the y axis?
It does.
Would E be on the y axis and H be on the x axis?
Yeah. The x is the cause and the E is the effect, essentially. The y is the effect. So yeah, your electricity, you don't use more electricity because you've got a bigger bill. If you use more electricity, you would get a higher cost. So you draw the graph. How do you draw a graph of these points?
Would you like for kilowatt hours, it'd go up in probably like tens. Maybe
Yeah.
that's too little. It could probably be a bit higher.
And so what coordinates will be on the line?
0 and 45, 15 and 46.8.
Yeah, that's okay.
Yeah.
So draw a graph of that data. So 0, 45 is going to be a strange one because that's there.
Yeah.
And then we've got lots of other stuff going on. It looks like it's something like that. Hang on, this is a bit, I skipped a bit. Okay, so I now might need to go back. Let me see this one. New websites. Maybe. Alright, I'll now go back. This one. Okay. You're given this data. They said draw the graph. I just gave you the graph here. Part A. Any idea what this is about?
Is it just asking whether or not like the graph is suitable, like the way it was drawn?
So excuse me. So you heard a lot about you know, an exponential graph. Exponential graph looks like this.
Yeah.
Quadratic graph sometimes looks like this. You know, different things. Sometimes you'll have a trig graph and so on.
Yeah.
What you hear is about coronavirus. They're saying they're using an exponential model. That's because they'll say like day 1 the cases are small, day 2 cases, and then it's suddenly like rapidly increasing. In the early days, they had like limited data, so they were using a quadratic model. They said it looks a bit like the right side of a quadratic equation. Now they have more data, so they're using an exponential model. So they just create some equation and they just plug in the numbers. So days, people, whatever, and that gives them different values.
Yeah.
What they're saying is for these points, would you use a linear model?
Yeah. Because it goes through all the points.
Yeah, it really looks like it's definitely not quadratic or a curve. It's a straight line model. So yes, and that's because they all lie on or very close to a straight line.
Yeah.
Okay, part B.
So for part B, would you need to work out the gradient?
Yep.
Okay.
How would you do that?
So we have the coordinate 0, 19.
Yep.
And we can also use would that be the second point? Would that be like 10, 17 or 18? I can't tell if it's 17 or 18.
17.8.
17.8.
So that's fine. If all of these points are on the line, then it's fine. what I would recommend is you use the first and last.
Yeah. Okay. So 123.5.
Yep. So 1 second. So you said the gradient. So they want, what is this referring to?
That's referring to y equals mx plus c.
Yes. Do you remember a method where we can get the gradient and c all in one go?
Is that where you like do the reciprocal or something? I forgot what it's called.
Simultaneous
Oh yeah.
equations. So you'd sub them both into mx plus c equals y.
Okay. Should be m. Will be 0m.
Yeah.
Plus 19.1.
Plus c.
Oh yeah, plus c. Equals 19.1.
19.1, yep.
And the other one would be 120m plus c equals 3.5.
Yeah.
Maybe put it into the calculator.
Uh-huh.
So x is minus 13 over 100.
Okay.
And y is 191 over 10.
Over 10. And so the calculator says x and y. What are they really?
X is time in seconds. Or t.
No. From our simultaneous equations, we didn't have x and y.
Oh, it's m.
And
That one's d.
we didn't have d in our simultaneous equations.
Oh wait, would it just be y then?
We didn't have y. What letters were in our simultaneous equations?
Oh, it's c. Sorry.
Yep. So that's m, that's c. And so what is the equation of the line?
D equals minus 13 over 100, and then t plus 191 over 10.
Well done. That's good. Okay. Question C. Interpret the meaning of the coefficients a and b.
So, is c the y-intercept?
Yep. And so
b is the gradient. Wait, no, a is the gradient, sorry.
yeah. Interpret would be in the context of the question. So if the y-intercept is 19.1 or 191 over 10, same thing, what is that in terms of time and depth of water?
Well, it says the time is 0, so the time would be 0.
Yeah, so at time 0, the depth of water is?
19.1.
Yep, and time 0 is another way of saying the beginning.
Yeah.
So a container was filled with water, a hole was made in the bottom, okay. And so, yeah, the water started at a depth of 19.1 centimeters, something like that.
Yeah.
Okay, how about A? Interpretation for A.
Oh, right. So when would it be when time is 0?
So we did that one. That was B, the intercept. Now we have to do an interpretation of the gradient. Minus 13 over 100, or minus 0.13.
So would it be when the gradient is minus 13 over 100?
Gradient is always minus 13 over 100.
Okay. So wouldn't you just like explain, like say the depth of water is 19.1, so when the depth of water is 19.1, the gradient is always minus 13 over 100.
So we gave them the gradient, minus 13 over 100.
Yeah.
And they wanted explained in terms of the question. So like how we did here, for every 1 gram increase in mass, the spring extends by 0.05 centimeters extra.
Yeah.
So how about this one?
So it'd be every 1 decrease in time.
Okay.
Increase in time.
Yep.
The depth of water is decreased by minus 13 over 100.
Well done. Yeah. And it's in seconds. So I'll say every second the depth of water decreases by I think it's 0.13 centimeters.
Yeah.
Well done. Yeah, so the water starts with a depth of 19.1, and then every second the depth decreases by 0.13 centimeters.
Yeah.
Okay, and then part D.
So when it says use the model, like, does it mean like the graph?
It means the equation.
Okay.
And so how can you use the model to find the time when the container will be empty?
So would you have to rearrange the time to be at the front of the equation?
You could. So what would you do at that point?
Would you substitute the depth of water as 0?
Well done. And I can just do that right away. So I can just say the depth is 0. So 0 equals minus 13 over 100. I have to call it x plus 191 over 10. And you could rearrange it to make it, x equals or t equals. So it looks like, what does it look like the answer is?
Pardon?
And so what does it look like the answer is for this
147 seconds.
Well done. Yeah. And that looks about right on our graph. That's like 120. I thought it was wrong for a second there. So time is 147 seconds. So I'm just short on space. But yeah. So now all this stuff that we've been doing, gradient of straight line, all that, we're now putting it in a real world context. So
yeah.
This is what everyone says they want. Maths for real world. Nobody really wants it.
Yeah.
So you fill a tank up with water. You put a hole in the bottom. You measure the depth at 10 seconds, 30 seconds, 60 seconds. You plot the points on a graph. It looks like a straight line, and so yeah, they'll mostly fit on a straight line, so a linear model is appropriate. The linear model you use, you take 2 points, the first and last, and get m and c using simultaneous equations to give you the equation for the model. Interpret is the in the context of the question. So the water starts at 19.1 centimeters and it decreases by 0.13 centimeters every second. And then, let D be 0, and that'll tell you at what time the tank is empty.
Yeah.
Any questions about that?
No.
This is good stuff. Let's see this thing. Okay, how about this?
So this says write a linear model. Does it mean it wants an equation like a graph?
Yeah, it's like equation of a line.
Okay. So first it starts y equals mx plus c.
Mm-hmm.
So would p be at the start of the equation?
Yeah.
So it'd be p equals, would it be tx?
T is the x.
So it'd be mt
Yeah.
plus c.
Yeah, so instead of x and y, it is t and p.
So then do we substitute numbers in now or not yet?
Yeah, you could sub in numbers.
Okay.
So let's see. So this was the initial value.
So that would be, so for p, would you sub in the year after?
For p, you could. Go on. What are you thinking? So like 18,500. Take away that, is it?
Mm-hmm.
Oh, sorry, plus that because it's increasing.
So would C be plus 350?
M is 350 because that's what it's going up in.
Okay. So it'd be 350 equals. Oh, would it be P equals 350?
P equals 350T plus C. And if we go back to this one, so the gradient was what it changes by for every change in time. The 19.1 was the initial value, and that was like the plus C.
So is the initial value 18,500?
Yep. And so answer for this one.
Wait, so would it be P equals 350T plus 18,500?
Yep. And that's the equation of the model for this one.
Yeah.
B. Why might this model not be realistic?
Because it won't constant. There won't be a constant increase of 350 each year. It'll probably get higher over time when time increases.
Why would it get higher?
Because there's more people, I guess. The population.
So that's a very good thing. So it's more like an exponential model.
Yeah.
Exponential model. Yeah, so you have double number of people, you should have double number of growth. Exponential model would be more appropriate.
Yeah.
For population growth. I know the answer that they were looking for. There's another possibility. they're going to run out of resources. They'll run out of space. They'll run out of food. I mean, you can't have like,
Yeah.
a billion people, forever and ever and ever. Eventually
Yeah.
it's going to be full. Let's take a look. The number of people living in Bradley Stoke would probably not increase by exactly the same amount each year. Okay, that's not bad either. Yeah. So it's just a kind of rule of thumb. I'm not crazy about that answer though, I have to say. In general, it goes up by 350 every year, and so the gradient is 350. The initial starting value was 18,500, and so that's the C, like when that's where it's starting from. So it would be like 18,500, and then it goes up by 350 every year. Okay. Unless there are any questions, I bet it is exam time.
Okay. So for question A, do you need to link both company A and B's costs and days together?
Yeah.
So would you add them together then?
You would do them as like two coordinates. So 6 days, £7,100.
Yeah.
13 days.
And then could you solve them as simultaneous equations?
Yeah.
So it'd be 7,100.
It is mx plus c equals y.
Alright, yeah. So it'd be 6m plus c equals 7,100.
Mm-hmm.
And the other one is 13m plus c equals 9,550.
Sorry, it's 9,550, was it?
Yeah. And so x is, or in this case, m is 350 and c is 5,000.
Okay. And so write it in this form.
Do we know what c is though? We don't, do we?
It's y essentially. Like they're not using y and x, they're using c and d.
But isn't y just 7,100 and 9,550 added together?
No. In general.
Okay. So c equals 350d.
Yeah.
Plus 5,000.
Yeah. It's just another way of writing y equals 350x plus c. Sorry, plus 5,000.
Yeah.
The y is the cost. They usually use capital letter for a formula. And then the x is often time. In the real world, x is often time. In this case, the time was days instead of t.
Yeah.
B.
So would B be written as when 350 days have passed plus 5,000 to the cost?
No. So what would be an interpretation of 5,000?
1.
That would be, so our C for the previous one was this one. Our C was 18,500. What did that represent?
The amount of people that are living there.
Yeah. And the 19.1 was, C was 19.1 for this one. What did that represent?
The depth of water.
When?
When time was 0.
Yes. This was the number of people at time 0, like at the beginning. And so, interpretation of the 5,000?
So, is 5,000 when it's 350?
No. 5,000 is for 0 days. It's when time is 0. It's like the initial amount.
Oh.
Or in this case, it's like a flat rate. So
Yeah.
even if you do 0 days, it's still going to cost you 5,000 pounds.
Yeah.
Is the cost initial cost or something? Like starting cost.
Yeah.
Okay. Interpretation of the 350.
So, is it like for every... For every 1 day?
Yep.
Plus 350?
Yep. There is a £350
Increase
in, and in general Y, or in this case Y is cost.
Yeah.
Okay, let's see.
Okay. So first, would you just minus 5,000 from it?
Yeah, okay.
So 50,000. It's 8,400.
And then?
And then you just divide it by 350.
Yeah.
Which is 24. 24 days.
Looks good. And if I just put it in like that, shifts off 8. So answer checks out. Oops, that's good. Let us see. And I really didn't read this question. So there's a website designer. He charges a flat fee and then a daily rate to design websites for new companies. Yeah. And so another word is 5,000 is the flat fee.
Yeah.
And then £350 is the daily rate. Yeah. Grand. Any questions about that?
Nope.
So you're definitely good for C. That thing there, okay. Let me see. Okay, what is part A for this?
So do you do them as simultaneous equations first?
Yeah, go on.
Okay. First one's 20m plus c equals 68. And the second one is 9m plus c equals 48.2.
Well done.
So that would be so x or m equals 9 over 5 and c equals 32.
Yeah, and 9 over 5, that is 1.8. Same thing. Okay, so what is the answer for A?
F equals 1.8 A.
Let's see.
Would it be 1.8 C?
I think it's C, yeah, because these are C and F.
Okay. 1.8 C plus 32.
32. Okay, B.
So when F is 0, B is 32.
Other way around.
So when B is 0, F is 32.
32 is B. When C equals 0,
Zero.
F
F
equals
is 32.
32. Yeah, that's it. So that's the interpretation for 32. What about the 1.8?
Okay. So is it just C's increases everyone, it increases by 1.8?
So for every 1 increase in C in degrees Celsius, go on.
1.8, is it just 1.8 is added or increased?
To what?
32.
No.
To F.
Yeah. So for every 1 increase in X, there is an M increase in Y. For every 1 increase in C, there is a 1.8 increase in F. That's good. I just want to check something. 0 degrees Celsius in Fahrenheit. Yeah, it is 32. That is it. 9 over 5 plus 32. Okay. That's weird. Their freezing point is 32. Okay. Unless you have any questions there, I think we're good.
Yeah.
Let me see. What is part A?
Well, it can be approximated because the points are still mostly in line with the line of like the weights going up, the increase.
Yeah, most of the points lie on or close to the line.
Yeah.
Therefore, a linear model is appropriate. Hey, yes, cool. And so, What do you give yourself for that stuff?
Probably between a tick and a half.
That's great. I'm happy there. Okay, so that's that stuff. Next chapter is circles, which we started a little bit by doing midpoint and perpendicular bisector because they are straight lines. Well, we did this. That seems familiar. This was the length. Oh, the equation of a circle. That's it. It is not the length. Okay, equation of a circle. So this is going to be totally different. Hang on, before you might hate me too much. This was the old one. So let me, 1 second. So modeling with straight lines, yeah. If x increases by 1 unit, y increases by k units. So that's how you can interpret the gradient.
Yeah.
Gradient is fine. Y-intercept is fine. Instead of using y and x, you use the letters that they're using, m and e, whatever they might be. An interpretation of the y-intercept is like, if it's time, it's when the x is 0. That's basically it. No, I think you're good. Okay, so this is totally different. You have a circle. Its center is 4, 5.
Yep.
You have another point. It's we don't know them, but it's just x and y because we don't know them. We know the circle has a radius of 3. It has a center of 4, 5, and so the length of this at the bottom will be x take away 4, whatever number x is.
Okay.
The height of this point P will be, the length of this line will be y take away 5 because it starts at 5 up. Use Pythagoras to find the, how would you do Pythagoras for this triangle? Just using their letters. How would you make an equation?
So would it be x minus 4 squared in brackets?
Yeah.
And y minus 5 squared in brackets equals c squared.
Yeah, and what is c for this one?
Oh, it's 3.
And so 3 squared is fine. Yes, so in general, all circles can be written in the form of x minus a squared plus y minus b squared equals r squared. The center is AB.
Yeah.
And then the radius is the square root of whatever's on the right side.
Yeah.
Square root of r squared, whatever. Yes, and that equation will produce a perfect circle. Because it's Pythagoras. Okay. How about this?
So it'd be x minus 5
Yeah.
in brackets squared plus y minus 7 squared equals 4 squared.
Well done. And they might write it as 16.
Yeah.
Yeah, they turned it into 16. Nothing wrong with that. That's okay. Great. Okay, how about this one?
Okay. So we use Pythagoras to work out r, right?
Yep.
Does it matter which coordinates you use for the Pythagoras?
You need both.
Okay. So it would be 4 minus 1
Yep.
squared in brackets,
Mm-hmm.
and then plus 2 minus 2
Mm-hmm.
squared in brackets equals r squared.
Yep.
And then can you expand them?
Simplify first.
So it'd just be, in the brackets it'd be 3
Yep.
squared plus 4 squared. So that'd be 9 plus 16, which is 25. And then you square root that, which gives you 5. So the radius is 5.
Yep. And part 2.
So the equation just be x minus a squared
What is A?
minus 1.
Yeah, because that's the center. X minus 1 squared.
And then plus y minus 2
Minus 2.
minus 2 squared equals 25 squared.
You have to pick one. It's either 5 squared or 25.
Oh, 5 squared, sorry, yeah.
Yeah. And what is y minus 2?
Y plus 2.
So that's a bit, that's a bit simpler. And you could also write it as 25. Great. I think you're good. Okay, how about this one?
Okay. So the center is minus 3 comma minus 4 minus 3 4.
Other way around. 3 minus 4.
Oh yeah.
They're the opposite sign.
And the radius is 5.
Hey, radius isn't 5.
Oh wait. It's square root of 20.
Yeah, square root 20. B.
So for this, to work this out, would you need to substitute 5 and minus 8 into x minus 3 squared plus x plus 4 squared? What y equals y plus 4 squared.
Mm-hmm.
So it'd be brackets 5 minus 3 squared plus brackets minus 8 plus 4 close bracket squared equals 20.
Yeah. Well, don't write equals 20. Just work it out.
Okay. Yeah, so it'd be 4 add 16 equals 20.
Yeah. That equals 20. Show that question. So what's the last thing you have to say?
Therefore,
Yeah.
It's showing that
Just copy.
Five.
Copy paste. The circle passes through 5 minus 8.
Okay.
Yeah. Great. Any questions there?
Nope.
Okay. Good. We're doing well. Alright, here we go. We're off to the races. How's about this one?
Okay. Okay. So first we find the midpoint.
Mm-hmm.
Which is 4,7 minus 8, minus 8,3 should be okay. Wait, no, you add it divided by 2, don't you?
Yeah, I wasn't sure if that's what you were saying.
No, it wasn't.
Okay.
So the midpoint is minus 2,5.
Minus 2, 5. Okay.
Okay. And then it doesn't really matter if you use 4, 7 or minus 8 and 3.
For what?
Like when you work out like when you're using Pythagoras, it doesn't really matter which one you use.
Okay.
The 2 coordinates.
Yeah, it doesn't matter.
I'll use 4, 7 then.
Yeah, definitely.
So it'll be written out as 4 minus 2 in brackets squared plus bracket 7 minus 5 close bracket squared equals r squared.
Mm-hmm.
And then you work it out. So 38 is r squared, so the square root is just the square root of 38.
Sounds good to me. Squared. Shifts off. And so we want the equation of the line.
So the equation would be brackets x minus 2 close bracket squared plus y minus 5 close bracket squared equals square root of 38 squared.
What is the square root of 38 squared?
38.
38. Let me see. Yeah, and I would just make it x plus 2.
Yeah.
Let me just... No, I won't mess with that. Okay, I think that's great. That's beyond my wildest dreams. This one, let me see. Okay, that'll be for next time. Yeah, how was that for you, Adam?
That's great.
So because we did that straight line stuff already, you're very good. How are you so good at this Pythagoras stuff?
I don't know.
Most students need to draw a circle and visualize it. But anyway, I'm not complaining. And so we'll continue this next time.
Yep.
Okay. Any questions in general?
Nope.
All right. Well done, Adam. You did great.
Thank you.
Look forward to talking again next week.
You too. Bye.
Goodbye.